This is a short video on 1.6, which is classifying polygons. First of all, a polygon is a closed figure made of line segments. Put a bunch of line segments together and it's a closed figure that makes a polygon. The first one is a polygon because it's made up of line segments. If you look at the set sides, these are all line segments. This is not a polygon because of that curve. You also can add to this if you have something like this, that would not be a polygon because it's considered open. There's two different kinds of polygons. There's convex and there's concave. Convex polygons, if you extend all of the sides, you will not go through the inside of the figure. If you look at this one, I can extend all the sides and you never go through the inside. A concave polygon, if I extend any of these sides, you see how it goes through the middle right here? That means it's concave. With this example, this is concave because if I extend a side, it goes through the middle. You can also see how there's kind of an indent on both of those examples. There's no indent on convex. A regular polygon, it has all sides the same length and all angles have the same measure. Typically you will see either the word regular or you'll see these markings that show all angles are the same and all sides are the same. Here's another example here. I do want you to know the formal names of sides of, let me try that again. I want you to know the formal names of figures up to 12. After 12, there are formal names, but I'm not going to ask you to memorize them. So I'd like you to know these names. After 12, we can call it an n-gon. So let's say 13-gon is a 13-sided polygon, or 15-gon is a 15-sided polygon, or 32-gon is a 32-sided polygon. So memorize these. Remember, these are not necessarily regular. For example, a hexagon is a 6-sided figure. It can be regular, it does not have to be. Equilateral polygon, all sides are congruent. Equiangular polygon, all angles are congruent. So if it's equiangular and equilateral, it's therefore called regular. I'm going to ask you to name the figure. Looking at my first example, we can count 1, 2, 3, 4, 5 sides. It is a polygon. It is a pentagon because it has 5 sides, and it is convex. I cannot call this regular because I don't know if all the sides are the same and the angles are the same. Again, you cannot assume. This example is a regular octagon. Again, if you count the sides, we have 8 sides. That's what makes it an octagon. It's a regular octagon because all of the angles are the same and all of the sides are marked as the same. And it is convex. So regular or not regular, you don't have to put in the word not regular. Name it by the number of sides and also if it's convex or concave. The next example, it says the figure is a regular polygon. That tells me all the sides are the same. Find the value of x. Our first example, because we know the sides are the same, we can set this side length equal to this side length and solve for x. So that's exactly what I did here. This side length equal to this side length. When I move this x squared over here or move this x squared over here, either way those x squared cancel out. At my next step, what I did was add 5x to this side. That's where the 11x came from. I added 7.5 to this side. That's where 49.5 came from. Divide both sides by 11 and I get 4.5. On my triangle, and again, they're asking us for the find the value of x, and we did. On the triangle, we have 2 sides that have expressions and are asked to find the value of x. So I set this expression equal to this expression. In this case, I subtracted x squared and put it over here to get my variables together. There's my x squared because 2x squared minus x squared gives me x squared. Add 61 to this side, that's where the 49 came from. So negative 12 plus 61 gives me 49. To undo this square, we're square rooting both sides. So the square root of x squared is x. The square root of 49 is positive or negative 7. Now you always want to double check and see if that works. If I plug in 7, of course 7 squared minus 12 will give me a positive number. 2 times 7 squared minus 61 will also give me a positive number. Negative 7 will also work. Negative 7 squared gives me a positive number. 49 minus 12 gives me a positive number. If it gave me a negative number, we would have to take that -7 out of our solution. It does work in both cases, so -7 and 7 are the values of x.